All right, let's start. Let's start.
Custom tailored dress. Yes. I know.
Wow.
Questions on the homework. So we can work them for sure, or we can just see if there's questions, right? So on the simpler ones, usually we just see if there's questions and we compare our solutions, that kind of thing. Remember, you're supposed to have a different colored device in your hand if you want to write.
Oh,
All right, that's this one, right? 8.
yes.
This individual started going east. I tried to draw it to scale. That was my plan. I was actually going to go into AutoCAD and just do it in there, but I didn't do it. Started east, went 2 miles, then went southeast 3 miles, then went north 6 miles, and then went southwest 6 miles. And my little scale put it down and passed. I don't know if that's correct or not, but yeah, so there you go. How do we solve this thing? It's not a triangle, so you're not going to do the sine law with that thing. Yeah, so I call them east values and north values. You're going to see how far this individual went to the east and then back, and then that'll set up this east offset, right? Did anyone do it that way? I know Evan did. Anyone else do it that way? Yeah. So what'd you get for your east offset? That.
0.3626 to the west.
0.3
No.
to the west or to the east?
1226 to the west.
Evan, what'd you get?
I got 0.12132 to the west. I was just
So that could be rounding. Yeah,
Yes.
that could be rounding. Anybody else get a number? Nick's on it still. I know.
I'm just writing down what
I got it. All right, do you want to work it? Like,
that is the east.
so here's the east value for the 3. Here's the east value for the 6, right? East of the 6. This would be east of the 3. And it's just right triangle stuff, right? So we can write out the first one here. This would be what? Cosine. So cosine 45 equals, I'll call it E3. This is this east 3. And I set up positive, to the right and negative to the left. Over 3 miles. Agreed? That's this triangle right here. Yeah? Yeah. So E3 is 45 cosine 3 times. So it looks like 2.1213 miles. So I would put that in this is my summation of my easting. So I have my 2 miles and that's positive. Then I have another 2.1213 miles, just collecting, to the right. Now we're going to go back the east part of this 6 miles. Yeah.
So for the 6 miles,
Mm-hmm.
I just doubled the numbers from the 3 and then checked my answer and it turned out to be
Yeah.
right.
Yeah, that's an assumption. Yeah, you can do that. I'm going to calculate it.
Yeah. Well,
So a lot of those things, if you don't see it, you just calculate it out, but you did it anyway to verify. So yeah, that works. All right. So this one I want now, right? Or you can draw it kind of down here, however you want to draw it. So here's our 45. Going to be cosine again, right? Now I'm doing this triangle. Cosine 45 is going to be E6 over 6 meters.
Well, does it matter if it's cosine?
No, but the way I have it drawn, right? I would want to use cosine. That would be appropriate. If I put the E6 here, that's kind of weird because that's northing.
I'm
So
just saying,
no, it doesn't matter.
It's
You're right. Equal
same
legs.
length.
I totally agree.
You could
I
also, if you set,
Totally agree.
if you set up the triangle where the bottom is like in the graph is sine.
I mean, the assumption is everyone knows that a 45-degree triangle, right? Maybe everyone doesn't, or you just didn't see it or whatever. Sometimes I don't see that stuff and I just like work through the trigonometry and just go for it. E6 equals. Probably the most important thing here is you get decent drawing and you get decent notation because the goal is somebody else can see what you're doing and understand it, right? So if you're solving for this, then it should be noted, right? And the angle and the side, so somebody can kind of put it together. Other than you. 45 cosine 6 times should be 2 times, as Evan says, should be 2 times of that. Looks like it is. 4.24264. And that's going this way, negative. So I'd put that in negative 4.24264. And then that's going to equal your offset in the east, right? I'll change the sign, I'll add, and then I'll add. So I do get a negative, meaning that it is east of where she started of 0.12132 miles. Close, 1/10 of a mile from where we started in the east. So then you got to go through the whole thing again with the north, right? Because it's down here somewhere and it's going to set up both east and north. Yeah.
You also, since it is a 45, the east and the north are the same. Because it's a 45-degree and 90-degree.
And because the distances are similar, you're thinking?
No,
I would calculate.
you don't have to calculate the numbers because it's a 45-degree triangle. Both the sides that aren't the hypotenuse are gonna be the same.
Right.
So you don't really have to do a triangle calculation.
So you're saying it's also 0.121 in the north.
No,
Okay.
because you have that 6 meters, so you're going down 2.1,
Right.
up 6.
So you're saying you can use the values
You can use the values
of the 45s. Absolutely. Yeah, it's a 45. But again, you'd have to, I mean, the assumption is everybody knows that and everybody saw that, right? If you didn't see it, you would just calculate it out. All right. So this is the 3-mile number. This is the 6-mile number. That's what Evan is saying. And those numbers are good in the north also, right? So if I do my north, looks like they drop down. So I'm going to put in a negative, the 3-mile number, 2.1213, right? That's this one dropping down. Then we have a plus 6 miles going straight up. And then we need the side or component of the 6 miles, which is this thing. And that's coming down, right? Minus 4.24264. Yeah, we like it. It's so early, isn't it? Everything's just like, whoa. It's not that early for me. I've been up a hot while. So, what number did we get?
negative 0.36396.
6. Juan, you close to that?
626.
Sean, you close to that?
I heard when I was doing this, I forgot.
Okay.
Negative sign, so it's a little off, but
A bit. You have her in Kentucky or something. This is what I get, 3, 6, 3, 9. I get 4 there, but pretty dang close. All right, so then what did the question actually ask?
How far away is she?
So what do you think we need? We need the the hypotenuse. All right, how far away is she?
0.38 mile.
Delightful. Story problem. We got to get lots of those. Questions? What was the big assumption on this problem? The 45 degrees, right? The southeast is 45. But I think it said it, didn't it, in the problem statement? Didn't it have a 45? Yeah. All right. 10? Does 10 look like that? I just took them out of my book. Okay, good. So one side of a triangle is 100, right? And then the opposite angle was 55. Yeah?
Yep.
And it was a right triangle?
Yep.
Yep. And 63 was the other angle. And they wanted to know what? Oh, the circumference all the way around. Yeah, they're gonna fence it. So we need C and we need whatever you want to call this, B. How do we get C? Yep. Why did you choose sine? Yeah, because we're gonna use the opposite over hypotenuse and we want to use what we know, right? We don't want to use cosine because that's unknown, that's adjacent. So you're gonna choose your function based on what you know, and you know this and the opposite side, that sets up sine. 100 feet over C. What do we have for C? Rounded to 08.
Yeah.
Perfect. And then how are we gonna get B? Tangent would use the 100 that's given. I like it. Tangent 63 is opposite B over 100. Did you do it that way?
I did 55
Oh,
equals 100.
and that works too, right? Yeah. B equals my B or the base or however you do your drawing, different than mine. What do we get? 70.02 feet. How much fence do we need?
293.1.
293.09. Got a bad number. Uh-oh, just cruising along. You gotta stop me. Let's see what I get. 63 tangent 100 times. Ooh, I don't get 70. I get 196.26 feet. Anyone get that? Oops, let me do it again. Let me make sure I'm doing it right. 63.
The picture.
Yeah, it's not a right triangle.
It's not.
Yeah.
I asked if it was a right triangle.
No one else.
Oh my God.
So that's, I'm like, I was like.
All right,
I.
let's just see.
I guess I got it.
Yeah, that whole problem is just wrong.
Yeah, that's just bad. I'm just cruising along thinking, oh, we're gonna be done early here. Problems. What is this, number 10? It's kind of my fault because I must have copied it wrong or something.
No, it's just a word.
One side of a triangular lot is 100
I was confused.
and the angle opposite is 55 degrees. Another angle is 63. Sketch the shape. Oh, I didn't even do that. I just assumed it was a right triangle. That's bad. Yeah, they'll get you, won't they? All right, let's try this again. New piece of paper. We successfully mucked that up. But now I lost my little triangle.
thought I was being smart.
Sad.
So the red.
Yeah.
Yeah, it's a hell of a lot easier, right? Alright. Still going with 100 feet here. And then the angle opposite is 55. Is that right? Guess you just have to like, it could be up. And 63 is the other angle, correct? Well, opposite is 55. This is 63. This is 30, 60, 90. So we'll do that. Start it there. And then this is 55. So that's 30, 60, 55 is like right in there. Okay. Constructed it a little better that time. Oh. I don't know if that's right or not. We're gonna go with it. 55 opposite. And another angle is 63. So what's this angle? 62. Clearly not 90. Damn it. I did it too. Like I was all about that. Let's get this done. All right, so now what do we do? It's a different game, right?
I use side law.
Yeah, why the sign law? Give me a reason.
A side and then two angles.
That's right. No.
I mean,
I was so ready to say that's
side
right.
and then the
Opposite side. Yeah, we have an angle and opposite side, so that sets up the sign law. All right, I'm feeling better about our engineering firm at this point. 100 feet over sine, I'm just gonna write it this way, 55 degrees. Works better that way. Sign law, right? And I'm gonna label these other sides, A and B. And then we can go after either one. So I'll just put A up, and then the opposite is sine of 62. So you may have labeled it differently. Yeah, actually probably drew it differently too, but
Well, that's exactly what I did.
sweet. We're on the same page.
Sure, it
That's,
was the right time.
yeah, me too.
I did, but I just changed it.
All right, what'd we get for A? Now that we're somewhat tracking this correctly. Yeah, I get 107.
Yeah, sorry. 107.4.
Okay,
I got it on my letter.
that's all right.
Okay, but then the other one.
And we're at feet. Yeah, so this one is here, A, right? So it's opposite of the 62, if you're trying to keep track of this. And then how are we gonna go after B?
Same way.
Same thing, might as well just keep running the sine law. It's easier than the cosine law for sure. So we'll go 100 feet. Again, why not? Over the sine of 55 and B over the sine of 63. That was only like a 10-minute detour. Now we're 108. Yeah? Yeah.
Sign 62 and sign 62. Oh, for this one,
For this one.
times it by sign 62.
So
I went for.
Three 16.56.
Yeah.
Probably 317 if you're talking to a contractor, right? They're gonna be like, really? You want a half a fence thing? I don't think so. All right, that was number. Number was that?
10.
When did we screw up? 10. All right. We can go back to, if this is right, 11, shock absorbers and brakes. Yeah. Kind of a tricky problem, definitely a story problem, and you want to dissect these, right? You just want to, anytime you're getting a paragraph of information, you just want to start picking things out. What do you know and writing it down in some form. So I kind of did it graphically. I know that there's 8 shocks and 10 brakes in this box and it weighs 101. And then I know there's 10 shocks and 6 brakes in this box and it weighs 106, right? So somehow pull the information out of the story problem and put it in some other form, so you know what's given. So if you have 2 variables and you have kind of 2 setups, you can make 2 equations. And if you have 2 variables and 2 equations, you can solve that algebraically typically. So it's not a multivariable problem. It's 2 variables and 2 equations. Okay. Yeah, substitution is probably the easiest way. There's other methods, but substitution is by far the easiest. So you got to write the equations. I used S for shock, B for brake. You could use X and Y if you want or whatever. That's fine. I'm going to write the formula of the first one and the formula of the second one. You kind of got to do that. So I'm going to go 8S plus 10B equals 101.6 pounds, right? So that's the first box. And then the second box is 10S plus 6B equals 106.2 pounds. So 2 equations, 2 variables, same variables. We will get a lot of these when we get into moments. So lots of those kind of things. So the easiest way to do this is called substitution. And that's where you solve one equation for one of the variables in terms of the other, then substitute it into the other equation. Okay. So you can pick the top one, solve for S or solve for B, doesn't matter. Once you get it solved, then you're going to plug it in the other equation to eliminate one of the variables to get just all B's or all S's, right? And then you can solve for that. So I'll solve the first one for S. So how do we get S by itself? I'd get this term by itself first, right? Get this all by itself. So how do we get rid of this? We minus 10B from both sides, right? So we're going to end up with 8S equals 101.6 pounds minus 10B. That's subtracting 10B from both sides. Yeah. And then how do we get rid of the 8? Yep. 101.6 minus 10B divided by 8. So that gets S all by itself. You can do it a lot of different ways. Like you could solve it for B and then sub that in.
We did elimination.
You can do elimination. all kinds of ways, right? So what is this anyway? That's 101.6 divided by 8. It's just a number. So you can turn that into a number and then 10 divided by 8 and you end up with this 1 point something b, right? So it's not as complicated as it looks. Looks kind of mathematical, but it's really not too bad. Now what do we do with this s? Plug it into there, right? So we end up with 10 101.6 minus 10b over 8, right? Because that's my s. 10s, that's s, plus 6b equals 106.2 pounds. So that's subbing it into that equation. Again, it looks gnarly, but it's really not. It's not gnarly, right? Because this can just go to a number. This goes to a number, then the 10 multiplies through, and you end up with a B statement and a B statement, and you can just add and subtract those, right? To get to one B statement, then you just algebraically clear it out. Yeah? Okay. So what do we get for B? Or would you like me to do the algebra? That's up to you. I think you can do it. What? 3.2? And what are the units of that? Pounds. Is it pounds or is it? Yeah, are there any units over here? No. No, the only unit in this thing is pounds, so it's gotta be pounds. That kind of makes sense. Brake pads, 3 pounds. Maybe they're truck pads. Kind of heavy. Then how do we get shock?
Plug it into one of the equations.
Yeah, either equation. So we take the B up, we plug it in, and we can get the S number in pounds. What's our S number in pounds?
8.7.
8.7 pounds.
Good job.
Sweet. Well done. Mark that problem up. The last one was 37, correct?
Yes.
And that is a conversion? Is that conversions?
No.
Oh, damn. See, mine's different.
It's like a depth of a log.
Oh, is the log underwater?
Yes.
Ah, yeah. Mine's all just conversions, like I thought you were gonna really be stumped too, because one of them was PSI to megapascals. I'm like, oh, that's gonna twist their head up, but my book's different. All right, log underwater. Log underwater?
Yeah. I got the state.
It's all right. I just want you to like I think it's gonna be fun to have it confusing, so.
No,
Here's my log underwater. Now what else do I know? Is it sitting on the bottom?
Two fish, yeah, or-
the log's
Is it sitting on the ground underwater? Cool. And then there's water up here somewhere?
Yeah.
My log might be a little big. Oh. All right.
Yeah.
All right. Now what do I know? There's a fisherman over here.
Yeah.
I'm guessing he's in a boat. And there's one over here. Both the boats are pointing the same way. Like this. 85 meters?
Yeah.
Holy crap.
And the other 65.
Oh, shoot. Is it from the same spot on the log?
Yeah.
Oh, that's good. Right?
And the
This
other
one's,
65.
oh, 65. Sorry, dude, you're over here somewhere. This guy's not fishing, he's sailing. 65 meters, 85 meters. Okay, good. What,
100 meters.
we gotta know something else. Oh, 100 meters between them?
Yeah.
What else do we know?
That's it there.
Guess we know what to do now, huh? What? Coastline law, yep. Which is the long side? 100 meters is the long side, so I'm gonna set that up as angle C. Does that make sense? Right, so then I know that C squared equals A squared plus B squared minus two AB cosine C. Or cosine of the angle opposite of the side that you identify as C. That's the important piece, right? So I identified this as C, so that makes this 100. And then the other two sides doesn't really matter. 65 squared plus 85 squared minus 2, 65, 85 cosine what? C, which is what you're trying to find out. What they actually want to know. How deep it is or something? Yeah, okay. What's our strategy with finding out how deep it is? Like, this is the depth, right?
Well, so that up there where you kind of just made an angle,
Here?
yeah.
Yeah,
I found that angle, or sorry, on the other side.
you found this angle.
Yeah, and it was like, okay, so on the bottom,
Got it.
it's gonna be the same, and then I use, what did I use? Sine,
So did you do the cosine law with these two then?
yeah.
The 85 here, and you found
Yeah,
the opposite angle? Anyone else do it that way?
I did it different.
So you put it here? And then what angle did you go for? This one?
Yeah.
Yeah, so that's, it's the same kind of strategy, right? Yep. Yep. How did anyone else do it?
Okay, so I found the bottom angle and then.
This one?
Yeah.
Yep.
And I found the top left angle
Yep,
and then I'm pretty sure alternate interior angles apply, so the angle next to the log on the bottom left.
here.
No, on the other side of the triangle, right there.
Yep, those two are the same?
Yeah,
Yep,
so I use that to find the height value.
out
there.
here. Yep. Excellent. A lot of different ways to go after it, right? A lot of different ways to go after it. Love it. So what did we get for H? Meters. Yeah?
Yep.
Love it. I think he had to work the cosine law somewhere, right? There was no way around that? Yeah. It just depends on what angle you got and then how you built the right triangle from that. Excellent. Good work. That's a 40, those are 4 problems, right? That's a 40 pointer, man. That's awesome. Each problem's worth 10 points. We rack them up. Yep. So the first set is in, graded, right, and back to you. So make sure you have problem statements for all the problems before you turn them in. Nice, simple problem statements, fine. And then pass them to the west. Juan will collect them and bring them up. If you need to staple, wear the stapler. Huh? They got 54.
I got probably my rounding.
You never know. I can look. I have the magic book. Oh, but it's the wrong book.
You know.
Well, we might be able to find the problem. 37? Yeah. Look at that. They get 57.
I actually checked on a calculator, a triangle calculator, and it is 54.
That was right.
0.77.
So now there's some, yeah, this is good. This is good.
I'm gonna do it.
Book's wrong. Yeah, the book's, yeah. I was-
The book could be
I was
wrong.
stressing out so much,
Yeah,
and I was like, but I remembered you said.
Yeah,
sometimes
the book can
is
be wrong.
to trip us
Yeah.
up, and I was like,
Right now.
So now.
No, I don't know if it's,
Ready?
I don't know if it's to trip you up,
okay, well.
but I'm gonna calculate it too.
Book's wrong.
Yeah, see, the book's wrong, the calculation is wrong, we should just, if we're close enough, bam.
Yeah, we're within.
Thank you, yeah.
Yeah, with.
Or 3 meters.
All right, short break, and then we'll do some components, and then we'll do the quiz.
You don't need to find the degrees.
Okay, then.
You only need.
Yeah.
I
Oh.
haven't watched the first two classes yet, and I'm
Okay.
not in the class officially
You
yet.
can't get them.
Okay.
That's because you can't get them, right?
Yeah, I don't have access to them on
Okay.
Blackboard. Is there any way I can not take the quiz today?
Yeah.
And maybe
Yeah,
push
yeah,
that out?
yeah.
If
No
I can
problem.
get the classes, I should be able to take it. We don't have school on Monday, but maybe. on
I'm
Tuesday.
gonna see if they'll just add you,
Okay,
but I gotta do the,
I
Special projects part first.
Okay.
so I'll get that done. You'll
Okay.
see information come to you on that,
okay,
and then I'm gonna ask online just to add you in.
okay. Should I be looking for that in my email?
Yep,
Okay.
yep, yep.
Sounds good.
I did that here.
Yeah,
Cause it ends at, where'd you get that?
I looked it up, I just wanted to have, I wanted to have it spend.
Does the book have it?
I don't know, but basically when you're calculating, like, do this top row with a number, do the bottom row with a number, and then divide it in unit, and then do those.
Yeah,
Because it gets all fun.
Yeah.
That way, but we still got the same. We still got the
That's
same.
really useful.
We still got the same.
Oh, I slid it over to
Yeah.
you. It's right in front of your laptop.
Well, I think we, and Steve was right.
Comprehensive, it's a viable option.
Okay.
We got the same. No, yeah.
I didn't send you an email, but I don't think it went
We're
through.
the only ones
So-
like that.
Cause I was like.
All right, you are gonna do 12, 18, and 20 over the weekend. Okay? So you're gonna need to know components of a force, so we are gonna do that now. Which just did, by the way. In the easting, westing, northwest, southwest problem. You essentially use the components of the direction. So we're gonna talk, we talked about vectors last time. Right? Everybody remember that?
Yeah.
Here, I'll give you a tricky one. And we'll review. We got 400 newtons going straight up. Okay?
All right.
So what are the four characteristics of this point or this vector? What, let's give them to me though. Magnitude is what? What's magnitude equal to? 400 newtons, that's the length of the vector, right? Direction, what was that? Yep. So what's our angle? 90 degrees. Yeah, so we do refer to this as 0, right? Kind of same as AutoCAD. Horizontal to the right is 0. And then we refer to angles counterclockwise as positive. Just like AutoCAD, right? So this would be a positive 90 degrees. All right, what else do we have? Two more, sense. What's the sense? Arrowhead, which is up, right? Or positive Y direction. And then the last one is, yeah, point of app, which is point A. Okay, excellent. Now, the components of the force are the X and Y, and some books refer to it as horizontal and vertical. I don't recall which one your book does. But it's either X and Y components or it's H and V components. Either one works, but it's the effect of the vector in each direction.
Called the, vector,
So it does X and Y. Yep. So yeah, we will name our vectors. This one is actually named 400 newtons, right? So there would be a 400 Newton, an X component of it, and a 400 Newton Y component of it. All vectors have those two components, even this vector. Okay, so the magnitude of the vector is 400. How big is the Y component of this vector? 400. Yeah, don't overcomplicate it. It's simple. 400. It's all in the Y. So its Y component is 400. What's its X component? 0. So this is 0. This is 400 Newtons. So I like to show that one right away because every vector has two components, but one component can be 0. That's okay. Now, if we stick a vector like we normally get them, which is off at some angle, point C, and it's coming off of who knows what, but we'll just put the ground here. And we'll say it's at 50 degrees, right? So every vector has two components. It's an X and a Y component. It's the effects of that vector. So we draw them tip to tail. And you start at your starting point. So we draw them to represent the effect of the vector. So there's one, the X, and here's another, the Y. So this is the Y component, and I would note it like this, of the 400, and the X component of the 400. That's how I do it. I think the book probably does it that way too. That's pretty common. Building a right triangle. It almost always builds a right triangle. Right? Now, that puts the Cartesian coordinates, X and Y, horizontal and vertical. So I can tell you right now, we move that Cartesian coordinate around all the time. And if I looked at the homework problems right, you may have one that you have to rotate the coordinates to find out what's going on, like up and down a hill. So, for example, we could have some kind of a hill, right? And then we could have like cars driving up the mountain, going to the ski park. The truck, these trucks are cool. And then there's a Volkswagen. Volkswagens are cool, right? And they're all driving up the hill. But we might want to know how much weight of those vehicles is acting down the hill, right? So weight always acts vertically downward, weight of these vehicles, but we might want to know like how much of that weight is going down the hill. So this is where we rotate the axis and say, okay, this is X and this is Y. That's perfectly legal. So we can rotate the axis and then do the exact same thing that we're going to do right here. All right. So just keep that kind of in your back pocket. Oh, like we might rotate if we want to know what's going on, like in line with the hill, we have to rotate our axis to figure it out. Because then this sets up to be something like this, and that becomes the 90. Right? It's just a rotated right triangle. Same kind of problem, but it hurts our head to do that sometimes. All right, back to this one. How do we find out what the Y effect is of this 400? Yeah, the 400 is really this, isn't it? The magnitude or the hypotenuse. And we have an interior angle right there, 50 degrees. So if we want Y, it's going to be sine 50 equals Y component of the 400 over 400 newtons. Everyone understand this notation? Does that make sense? Y component of the 400. We're going to end up with a lot of forces, so we got to keep track of these components. Like, oh, this is the Y component. Huh? Yeah, so since it's a 400 Newton magnitude force, this is the Y, the up and down effect of the 400 Newton force. Might make more sense if I said, oh, Here's the problem. Right? Yeah, if this is the problem and we have 50, 40, 100, oh, that's bad scale, 200, right? We need to keep track of these vectors somehow. So here is the y of the 40. Here is the, I'll put it here, y of the 200, right? Follow me? That's why we do it, because it's going to get really complicated. All right, what do we get for this? Just sine 50. Oh, I did that right. Times 400. 306.4177. Anyone else get that?
Yeah.
And then we need the also the x of the 400. What's that going to be? Cosine? Cosine 50 is the x over 400. Is that correct? Doing that in my head. You check me on it. Yeah, it's good. What'd you get? All right. I got my units because these are the Newton effects in each direction, right? There's another notation that's very nice. It can either be, if it's positive to the right, this is a positive force, the x component of the 400, right? So it's positive, that's great. I would put a little vector positive to the right, and I would put a little vector positive and up. If you don't do that, I'm gonna look at the sign, and that's the direction I'm gonna assume you thought that you wanted, which is fine, right? Positive 306 in the y, yep, it is, right? Positive 257 in the x, yes, it is. This is just for me, when I do the work, this is what I do to keep track of that effect, yeah.
But those are switch this y.
Oh. Sorry. Sometimes my hand and my brain are not like together. Yeah.
Does it necessarily matter, because you could, well, no, never mind.
It definitely matters. Yeah, yep. Like, for example, if this was applied, if that 400 newtons was applied to some kind of anchor. So here's the ground, we have a spiral anchor coming up, we have an eye, and then we have 400 newtons, right? So that's like a real type problem. This is rated at 300 Newton pullout. Like, we can look it up, right? Some kind of helical anchor, 300 Newton pullout. Well, what do we calculate in the Y?
306.
306. We're in trouble. So that's why it matters, right? And definitely the direction matters. This is a pull up. This is probably rated, for shear also, which is that side effect. Because the ground is only going to hold so much load, right, to counter this. So potentially this thing could just roll over in the soil if it's in soil. So that's why we typically need both effects of whatever's going on. It's great that we know the 400, but it doesn't let us really do a lot of analysis. We have to break it into its components to think about what's going on in each direction. And then when we have multiple vectors, this is how we add them. We collect all of the x effects and add them together. Some x effects will be negative, some x effects will be positive, right? But then we'll get what we call Rx, the resultant x of a force system. Same with the y, we'll collect all those and we'll end up with Ry, Rx and Ry, of course, can give us the total, but it's not really as important. Like when we add them all up, this could be Rx and this could be Ry. Right? When we add them all up. These are the two things we really need. Sometimes we'll go after the total result load that is of value sometimes, so. But what you're gonna do now is just a lot of practice with finding the components. So just be careful with the sign. I'll be looking to see that your signs are correct and we have things that are negative, should be negative, or at least include the vector pointing in a direction. Because there's really, in this class, no such thing as a negative force. A negative force is a vacuum of some kind, and we're not doing vacuum work, right? But we are gonna have forces that are acting in the negative direction. There, Tom McCormick is happy.
Question.
Yeah,
Since we don't have class on Monday.
yeah.
We're still gonna go over on Monday.
Yes,
And then we have homework due on Monday.
yep. And I'll
We'll go over that as well.
probably. I always go over them. We don't always work it. It depends on whether we're confused or not.
Yeah.
If we're happy, then we just move on. If we're not, then yeah. Questions? All right, I think you're ready for your homework and you're ready for your quiz. I'm sure you're ready for your quiz. Oh, yeah.